now it's time to study the Hooke's law. By experiment, an English physicist, Robert Hooke, experimented that within the elastic limit, the stress applied on a spring is directly proportional to the extension produced. So this was later called Hooke's law. So what is Hooke's law? Within the elastic limit, stress is proportional to strain. So I'll write it. According to Hooke's law, within the limits of elasticity, stress is proportional to strain. So we can write that stress is equal to, whenever we convert the proportionality to an equation, we have to put a constant. Here I am going to put a constant like E, such that stress is equal to E into strain. Or we can say that stress by strain is a constant, that is E, and this E is called the modulus of elasticity. So stress strain relation, stress by strain is a constant, and this constant is called modulus of elasticity. So once again, taking a recap of Hooke's law, within the elastic limit, stress on a body is directly proportional to strain. So when you write the law, within that elastic limit is a very important term, because beyond the elastic limit, when a material is subjected to stress, it may not be proportional to strain. That we will deal with the stress strain curve in the further classes. But within the elastic limit, stress by strain is a constant. Stress is proportional to strain. Stress by strain is a constant, and that constant is called modulus of elasticity. So now we will discuss a numerical where the stress concept, the strain concept, and the modulus of elasticity concept is there. So the numerical is like this, that you can see in the screen. After a fall, a 95 kilogram rock climber finds himself dangling from the end of a rope that had been 15 meter long and 9.6 millimeter in diameter, but has stretched by 2.8 centimeter. For the rope, calculate the strain, the stress, and modulus of elasticity. That is the question. Of course, you can see the question. We will work it down. So what all are given in this question? The length of the rope is given. That is given as 1500 centimeters. Okay, 1500 centimeters. Then next given is, there is a change in length after that. It is given as 2.8 centimeters. Then what is the stress? It is asked. To calculate the stress, his mass is given to you. His mass is given as 95 kg. His mass is, here is the point here you have to note. Mass is 95 kg. If mass is 95 kg, what is the force that he can apply? That is his weight only, right? So the force that he is going to apply will be, as you know, the weight of a body is mass into acceleration due to gravity. So that is equal to 95 into 9.8. So I am giving some time for you to calculate it. Take your pen and book and calculate it. 95 into 9.8. So this is the force. And in order to calculate the stress, you have to know stress is force by area, right? So where is the area? So in that, the diameter is given to you, right? So what is the diameter of given there? The diameter is given as like 9.6 millimeter. So the rope can be considered as a cylindrical cross section rope. Cylindrical rope with a area like circular area as cross section. So what we have to do is that the area should be also be calculated, right? Area of the rope calculated. The area of the circular portion is pi r square, and you know that it is pi into the diameter is given to you d by 2 the whole square. So how will you calculate it? You have to go for a hook cube calculation, that is pi into the diameter is given as 96, so it is 96 by 2 the whole square, but it is given in millimeters, so it will be 96 into 10 raised to minus 3, so that also should be squared. 96 into 10 raised to minus 3 by 2 the whole square. So I have written it like this. You can go for a quick calculation and let it be like that. The area you can calculate it. It will be in meter square. So now all the things are given to you. So first of all we calculate the strain. What is the strain? Strain will be delta L by L. So what is delta L given in the question? It is 2.8 centimeter, because both are in centimeters. Here you need not convert it into meter, because both are in centimeters. That is, it is 1500 centimeter. So when you calculate it, what will you get the answer? You get it the answer as 1.9 into 10 raised to minus 3. And you know that there is no unit here. There is no unit here since we have calculated the strain. So now what is it? We are going to calculate the stress. So what is stress? It is force by area. So what is the force? It is 95 into 9.8. If you have given the answer here, it's okay. You can directly load the answer here. Otherwise, it is 95 into 9.8 into, then what is it? Pi, your value is 3.14 into 96 by 2 into 96 by 2 into 10 raised to minus 6. So when you do it, what will you get it as? The answer is 1.29 into 10 raised to 7. 1.29 into 10 raised to 7. What is the unit of stress? It is Newton per meter square. So that is it. So strain we have calculated, stress we have calculated. Then what about the modulus of elasticity is asked. What is modulus of elasticity? Modulus of elasticity E is equal to, you know the formula, stress divided by strain. So what is it? Stress divided by strain is, here stress is given as 1.29 into 10 raised to 7 Newton per meter square. Strain, which is not having a unit, 1.9 into 10 raised to minus 3. So when we divide it, we will get the answer as 6.84. 1.9. This can be taken as 1.3. So 1.3 divided by 1.9. So you can get it the answer as 6.84 into 10 raised to 9. You can get the answer as, and we know that our strain is not having any unit. The modulus of elasticity is also having a unit like that of the stress. So when you do this numerical, what all are the important points that you have to understand? Here, the mass is given. So this mass is contributing to the weight. So where is the force? You may wonder. The force is not given in the question, but you have to do it like that. 95 into G. This is a matter to be noted. And then area. Here look. Don't divide diameter by 2, then get the answer. Then you have to reload it here. No. This R can be written as D by 2. But you should be cautious that this diameter given in millimeters should be converted into meters to get the answer in meter square. Then all the equations is with you. Strain is delta L by L. Stress is F by A. E is stress by strain. We'll get the answer like this. Thank you.